कुठे आहे कालच्या ह्यावर आहे का ओरिजिनल म्हणजे तुम्ही जे आता व्हॉट्सअपला आहे का काय द्या
You we want to complete.
Yeah. Good afternoon to all. Is it my voice is audible?
Sir. Hello.
Good afternoon.
Yeah,
Welcome to
good
the
afternoon.
fourth class. Yeah, sir. Vajesh sir,
Yes, yes.
please introduce yourself and start the today's session, sir.
Yes, yes. I hope my screen is visible. Yeah, good afternoon, all. Hope my screen is visible
Is it visible, sir?
and audio also clear. Okay. Yeah. So
Yeah,
myself,
sir.
Dr. Wazid Pasha, I'm working as a senior research scientist and the National Institute of Advanced Studies. So my basic research on the how the vegetation linked with the interdisciplinary subject with a geo-socio-ecological and also the space technology. Say one of the interdisciplinary approach because we can't see vegetation as a single entity. It is linked with the geo-socio-ecological approaches. So recently, Government of India for such type of work they awarded with a BRICS Young Scientist Award to me. And since past 5 years, I worked earlier. I worked at IIT Kharagpur as a research associate, and NRS ISRO. I worked as a research scholar and a project scientist for 7 years. I'm carrying more than 1 decade of research expertise in the vegetation and interdisciplinary subjects such as satellite data, GIS, and the climate insights. So today's lecture, I want to give a more rather than the lecture, a more interactive session. The types of forest fire. I mean, the audience will enrich with the what is types of forest fire and what are the global trends in the vegetation fires and burnt area. So these two are very different. All should understand what is different between the forest and vegetation fire and the burnt area assessment. That in upcoming slides I will brief you. And the case studies from the India and other nations. Why fire is very important to us. Why we are monitoring through space technology, ground data, and the socio-ecological surveys. The how to detect the forest fires and burnt area using the geospatial technology. Overview of forest burnt area in India. The the last session I'll give 10 minutes for geo-portals for fire and burnt area assessment or products. Means in global there are various fire and burnt area assessment products are available that I will give. It will be useful for the upcoming researchers. So why we need to study the forest fires? So we know that ecological and climate and as well as the societal effects of the forest fires, especially most commonly used term called carbon emissions. In the recent past, especially 2024, there are around 3.1 gigatons of CO2 emissions happened at global scale, which is comparable to India's annual fossil fuel emissions. Means how much a mega nation, mega biodiverse, and as well as the mega populous country, demographic country like India emit the fossil fuel in a 1 year that is equivalent to that. That much CO2 emissions happened in the 2022-2024 due to fires. So what are the impacts of the fires on the tropical and the forest ecosystems? So it will create the habitat destruction. Means very dense forest. There are a forest fire happened. It will become a open forest. So what will happen if it become a open forest? That I will let you know in the next upcoming slides. It will create the forest degradation and reduce the regeneration capacity. So it will also create the smoke. Around 1.5 million premature deaths are happened annually according to the world data. So these are the negative impacts. So it is very important to understand the trends, trajectories of the forest fires in the world as including India. So if you see India specific vegetation fire trends and patterns and hotspots and drivers, if you see there are 50,000 to 70,000 large fire events happened in India. Why fires are happening in India? So that we should know that is when it is happening. That is called as a fire window. February to May is the fire season in India, especially Central India, Eastern Ghats, Western Ghats, and Northeast India represent the fire hotspots. Over 90% of the fires. Who put these fires actually? So these 90% of the above fires, I can say 95% of the forest fires are linked to anthropogenic. So the shifting cultivation, non-timber forest produce collection, forest floor clearance, fire frequency is increasing. So we know notable observations from the Odisha, Chhattisgarh, Telangana, Andhra Pradesh, especially in the Tirumala region, Nalamala forest, Maharashtra, Gadchiroli, so northeast states. So why Indian forests are more vulnerable to the fire? That you should know that the most majority of the Indian forest fire happened in the deciduous forest. Means that will shed the leaves in the spring season. That will create a strata for the and a fuel for the fires. So that's why these dry deciduous forests are most vulnerable and increasing fire and climate feedback due to the rising pre-monsoon and temperatures. So this temperature and the fire is mostly interlinked. So what are the global trends in the vegetation fires and burnt area? As I mentioned, 2024 is recorded the highest fire-driven forest loss ever. There are 13.5 million hectares of forest burnt globally. The fire caused 50% of the tropical forest loss. See, these burnt area due to fires more than doubled in 2001. These are all statistics available in the different websites. So I'm not going into the details. So these are the impact of forest fires. Now coming to the types of vegetation area forest fires. Why I mentioned vegetation area forest fires based on the location and geographical area, these fire behavior will change. For example, the fire behavior is determined by the fuel structure, means how much moisture content is available what is the weather condition. For example, in a dry deciduous forest, there is a rainy spell, so there is a less chances of getting burnt. So human interaction, different fire types are there. So what are the fire types? So they based on the vegetation fires, based on the fuel type, fire behavior, and the vertical position means the type of forest. The forest fire profile is mainly three types. Number one is ground fires. Number two is a surface fire. Number three is crown fires. The ground fires are, you can see in the picture, the ground fire means the burns the below affecting the soil organic carbon and humus layer and roots, and it will spread slowly but persistent for the long durations. Means it is like a underground fires. It's called ground fires. It is very difficult to detect, um, and the more long time carbon emissions will come from the ground fires. But it will not create or it will not destroy entire plant. It will not burn the entire plant or a tree. The second one is a litter or a dry grass or a low shrub or fallen branches, that is called surface fire. Above the humus layer, there is another layer called the leaf litter dry biomass layer that will happen. The most of the fires in India happened are the surface fire, uh, but it will also create some issues. For example, it will create a loss of regeneration. That kind of situation it will create, but it can be ecologically benefit for the nutrient cycle, degrading when frequent or repeated. But in the same area burnt every year, it will create a frequent fire hotspot, and which will not create, it will not regenerate the forest. It will give opportunity for the other species like invasive species. So crown fires are canopies either partially or fully burned. So this is very intensely and a rapid spread, severe ecological damage will happen. Means in this fire event, the active crown fire, entire tree will burn and major drivers of large scale forest loss. But in India, we don't have major events of crown fires, very few crown fires. So what are the causes for these fires are, one is natural causes, theoretically, and the second is anthropogenic. As I said previously, more than 90% of the burnt area or forest fires are happened due to human activities. So why they are clearing these all, why they are putting fire? Because of two major reasons: clearing the surface for making the taking the NTFP, non-timber forest produces, like collection of honey, collection of these gooseberry, collection of other, and like in other species they want to collect from the forest. For that they are clearing, and also they are clearing for the their cattle. Once you clear the grass, so next year after rains, the fresh grasses will come. So these are all the burnt area refers to the total land area. What is the difference between the burnt area and vegetation fire? Vegetation fire is a uncontrolled or a managed fires during the forest and grassland savannas, but the burnt area is completely different. After the vegetation fire, the total land surface area impacted by the fire is known as the burnt area. So So there are certain satellites or sensors are used for the vegetation fire monitoring using the remote sensing satellites. One is MODIS and VIRS, and the third one is Sentinel-2 and Landsat imageries. So fire uh, regimes are changing due to the climate change, land use change, and the deforestation. Now in this interesting graph, you can able to see the tropical forest loss increased by the 80% from 2023 and 2024. Now you can see the historical trajectory from 2002 to now. In the green, it is showing the loss to the other drivers, means forest loss due to deforestation, fragmentation, mining. There are other reasons are there, but you can see the how sorry, loss of uh, forest due to fire. That this colored one indicates the clearing of agriculture, logging, and natural causes. uh, that all because of the forest fires. This is the global trend. So if you see the global annual tree cover loss from the forest from the forest fires, the tree cover loss from other sources means other than fire is 370 million hectares, and the tree cover loss from the fire is 150 hectares, a million hectares. So 29% of the tree cover loss globally between 2001 to 2024 clearly indicates there is an increase in the fire events and fire driven deforestation in globally. So what are the countries are responsible for these loss? See, Russia had the highest rate of forest cover loss due to the fires. Average 2.6 million hectares lost per annum, and followed by Canada, US, Brazil, Australia. So in India, what is the rank of India? So India is not in the top five countries. So now top 10 countries we can see the tropical primary forest loss shifted 2023 to 2024. This Bolivia raised to second. After Brazil, the Bolivia raised to second due to the forest fire activities, the forest fire related deforestation. When you see this interesting graph, the Brazil, Bolivia, Congo, Indonesia, Peru, Laos, Cambodia. So the top 10 countries, the two major is Brazil and Bolivia. India is not listed in the top 10 countries. It is listed in the other tropical countries. Now you can see the how the remote sensing can help for the decision making. The hotspots shows the Latin America that were newly affected by the forest fires. So once you have a data with us and a remote sensing technology, when you combine these two, the primary loss of forest, like new hotspots, sporadic hotspots means persistent hotspot means continuously that area is losing forest, and also diminishing hotspots means earlier it was a hotspot, now slowly it is degrading, and intensifying hotspots means the hotspots of fire is creating intensified day by day. So year by year. That is what we can prepare through the geospatial technology. There are two case studies prepared by the World Research Institute. These two we can see. Now, wildfires are the biggest driver of tropical primary forest. Now you can see 2022, 2002 to 2024 tropical forest, 59.7% is lost due to permanent agriculture. But now you can see 49.5% of the driver mainly due to wildfires. So that's why it is very important to monitor the fire. Now coming to the Indian context, now we can see how to detect the second listed one is how to detect the vegetation fire or a burnt area. So before, as a layman language, you should understand the satellite imagery. We should go through the remote sensing principles: tone, texture, pattern, and association. So when you come to the tone, the burnt areas in a satellite picture always looks a dark brown or a black color based on the fire intensity and the severity. The second is a active fire. You can see the active fire hotspots are very bright when you compare to the burnt area. The second is a texture. The burnt area scars are rough and heterogeneous because when the forest going to under forest fire, we don't have a control on that. But when plantation burned, we can know the exact boundary. So how much area will be going to burn. So that's why this is very heterogeneous. And you can see when you compare with agriculture and buildings, they are very smooth and regular. So when burnt scar happened in the forest, they are irregular and rough in nature. The pattern, the fires are irregular, having the irregular boundaries, fallow wind and topography. So built up, or if you compare with the built up area is linear and geometric. So most widely used spectral indices is normalized burnt ratio, NBR, or a differential NBR. So what it will use? It will use the thermal signal and the tone texture pattern analysis. So how we can analyze this? I'll show one with the formulas. Spectral detection of forest fires and burnt areas using the remote sensing. We can use, I mean, how it will work? It will work on the principles of fire emits the strong thermal detectable mid-infrared and thermal infrared bands, where 3.9 micrometers to 10 to 12 micrometers, where you will get the high reflectance emissions or elevated brightness. In Modi's fire temperature indicator is 4 micrometer to 11 micrometer, that comes as a active fire. So active fire, when satellite passes, is there any active fire? It will detect. After passing, it will not detect because it's already passed. That is the reason we will get a active fire count. So here we will not get the area. So for this, we need to get a burnt area detection. This is a different one where it removes the vegetation from the burned. It alters the near infrared and sphere responses to get the spectral change. NIR vegetation loss, sphere, the short wave infrared band will identify the char, ash, soil. So the formula is normalized burnt area, burnt ratio, NBR is equal to NIR plus sphere divided by NIR minus sphere. Simple calculation. How much vegetation plus how much moisture, that divided by NIR minus sphere. These two are very important for the fire activities. Now you can also see there is a case study by our team. Um, One is how to use the satellite remote sensing for detecting the forest fires. So you can see the as I told previously, the shortwave infrared from one band 6, we need to use the specific bands for this. So in this image, I have used band 6, that is shortwave infrared 1.57 nanometer micrometer to 1.65 micrometers, and the band 7 and NIR band 5 I used for the preparation. So how, as a beginner of the remote sensing satellite data imagery or analysis, how to see these burnt area patches. So I'm giving an example of shifting cultivation, that is called Zoom in the local parlance in the Northeast India. So these are all Northeast Indian states. You can see the patches appears in the deep purple color. I have circled the current Zoom patches. That is a burnt area patch. So from there, you can see this is extract the current polygons of the particular year. For example, in 2026, you have taken a imagery and you extracted the current shifting cultivated RF fire patches. then you download the satellite data of 2025 and extract the shifting cultivation or burnt area patches, and you go with the 2024. So like this, once you go with the 4 or 5 years of data, now the GIS come into the picture. Now you go for the satellite um, data integration. Means you can go with the hotspot analysis. You can go with the shifting cultivation patch analytics. So all type of analytics will come once you extract the zoom or extract the fire patches. This is assessment of the shifting cultivation in this one. So what are the bands here useful for this? So mapping of fire affected areas using the Sentinel-2. In Sentinel, there are 13 bands. So you can see there are 12 bands here, but there are extra band of um, B8A. So this is also visible infrared band. So here most widely used three bands I will tell you. One is band 5, visible near infrared. The band 8 is visible near infrared. But you can see the nanometer, the central wavelength is 842. The band 5 is 705. So the B12 band 13, 20-meter band, that is long swirl. It is around 2190 nanometers. So these are also very good combination for viewing the forest fire, burnt area scars and regeneration. So as I previously mentioned, this is the best example of active fire and the burnt scar in the Kali Tiger Reserves of Western Ghats. So you can also see we have also visited on the ground scenario showing the large trees do not have impact, but the ground is having lot of impact with the forest fires, mainly the poor regeneration. And you can say most of the regeneration is impacted. So what will happen once this will ground fires or surface fires are happened? So it will create some invasion that I'll going to tell in the next slide. So once you have captured all the forest fires of different years, what you can do? So once we have a spatial distribution of fire maps for any study area, now you can go with the decision making, because government wants to do some intervention on the forest fire areas, high frequent forest fires in certain areas. You need to recommend, give a geospatial product that this is the hotspot one, this is hotspot 2, and this is hotspot 3. So where you can go for immediate conservation, where you can go for the level 1, level 2, level 3 conservation, that you can provide using the satellite remote sensing. So here Arunachal Pradesh, Assam, Manipur, Meghalaya, Mizoram, Nagaland, Tripura, different examples we have provided. So why it is impacting and emerging concern with respect to the Indian context? So why need to study? Because we don't have a ground fires, but we have a ground fires and a surface fires. Why we need to study this? Because we are not a largest global emitter of the due to deforestation, due to the forest fires. But why we need to study? Because the forest fires in India is surface fires mostly, and which create the forest degradation, and it will repeated fires prevent the regeneration. Because in India we have a lot of native vegetation with ethno-medicinal and very ecological important and aromatic plants are there. Those are very small in number endemic plants that will lost their regeneration, and convert these forest fires. um, um, Most of the times it will convert forest into open forest and a degraded ecosystem. These also impact the carbon and climate impacts. The fire reduces India's forest carbon sink potential, because repeated fires increase the open forest. Open forest will increase the soil temperature because of the prolonged sunlight exposure. that will increase the soil bulk density. That soil bulk density increases the soil hardness. Once soil hardness increases the poor regeneration and become a barren. So these are all the carbon and climate impact. Once this is surface is heat, it will impact on the climate. So increase vulnerability to drought, the drought and as well as the heat waves. So and also it is having risk of biodiversity. So habitat fragmentation, favor the invasion by fire tolerant invasive alien species such as lantana, chromalina. I will give brief examples of lantana and chromalina. These species are not from the India. These species are these called as the invasive alien plant species. They are encroached the fire impacted lands are open forest. They are from the northern part, North America, mostly from the North American part. So it is creating lot of problem to the society and as well as the cattle and as well as the biodiversity. And also human environment linkages. Fire are interconnected with the near forest settlements. The settlements which is near to the forest, they are more concentrated on the fire, and strong dependence on the forest increases the ignition risk. So these are all created a management challenge. So we can't prevent the forest fires. We can manage the forest fire using the geo-socio-ecological aspects using the satellite remote sensing. Now, the field observations in the Western Ghats. You can see we have visited the fields in Nagarhole and Madumalai National Parks. We have seen the entire ground flora is completely burnt and there is no regeneration. Natural vegetation you can see after few years it has become a invasive alien plant thickets, that is lantana camera. In the second photograph you can see the natural vegetation on the top. Entire ground flora is invaded by the lantana camera. The vegetation fires. So this is the very important global concern because it creates the loss of biodiversity and the. So what is the solution now? Now we understood it will create the greenhouse gases, it will generate the soil degradation and disrupt the ecosystem. So the solution is using the multidisciplinary approach, means field data, geospatial technology is essential for monitoring the fire spread and the assessing the damage for planning mitigation strategies. RSGS geospatial technologies provide accurately, timely, and enable better resource management and the emergency responses. Why we need to use the geospatial technology means you can't identify the all national or a global level fires using the ground data. You should have some ground data, but we can't monitor historical forest fires. Means you can't go back. Means last year forest fire area we can't measure now. That is the reason we need to use the space technology for timely, accurate management of the fires. So this data is generated by the Global Watch, and this data you can see the forest burnt area in million hectare from the 2012 to 2024. You can see 2019, 2016, and 2021. There are highest number of highest forest burnt area, vegetation burnt area occurred using the spatio-temporal clustering and thermal anomalies detected by the MODIS and the VIIRS. And the vegetation fire patterns and trends. In this one, India is experiences most of the forest fires noticed in the February to May month. Over 90% fire, as I told, it is due to human centric and due to grazing land and forest floor clearing, shifting cultivation and NTFP collection. And the forest prone fires are mostly deciduous. And you can see the central India, Western Ghats and Northeast India is the most frequent forest fires in the country. Now Another big issue is the stubble burning. So Kharif crop residual burning in Punjab and Haryana, we have seen a lot of news on the Delhi NCR, especially in the Kharif crop burning time. Lot of this PM 2.5, PM 10, that all impacted the New Delhi because it's a landlocked area surrounded by the hilly region. So we know the 80% of the fire counts are coming from the Punjab alone. Only 11% are coming from the Haryana. So we have analyzed 6 lakhs of Suomi NPP fire counts from 2015 to 2024. From 15 to 13 November, it is identified that 89% of the forest burnt area or forest counts, vegetation counts are from the Punjab alone. So detection of the trends in the Punjab, Haryana crop residual fires are, you can see from 2015 to 2024, it is a slightly declining number of fires. And how to identify the residual burning, I mean Kharif crop residual burning using the Sentinel-2 data. Now you can see the different circles. In the left side of the image, you can see the middle, there is a lake and surrounded by the big settlement. So that is a settlement tone texture, and also the red color patches are a crop in the crop plants, and the black color dark tone wala is a recent burnt field. One second. Yeah, the white patterns are appeared in this box is a harvested field. So you can also see the previous burnt. After putting the burn, they'll put the water. It is the typical nature of the agriculture, because most of the residual burning happened in the agriculture field, not in the forest. That is the reason it is very tough to detect the burnt area, because today once satellite pass, night they burn and morning they put the water. That is the one strategy. Now, how to detect the forest fires in the forest ecosystems? So in this one, I am showing the series Sentinel-2A 10-meter images, the forest burnt area, active fire, post-fire vegetation recovery. Now you can see the first image, the 5th March 2023. Roughly there is a 10% of the image is under fire. Now you can see the 10th March 2023 burnt area scars and active fires. You can see more than 30% of the area is under fire. Now 15th March and 20 March, you can see 60 to 70% of the area is under burnt. Now using one time period satellite data could not capture the full fire trajectory, burnt area trajectory. Hence, the multi-source, multi-temporal satellite data is very essential for monitoring the progressive fire in the study sites. So generally, we use 1 or 2 time period. For example, if you take 5th March image, you will not, you will get only 30% of the fire and burnt area. Even 10th March, you can evidently see the active fires, burnt scar, fire plume, you can see. But if you take 29th or May or 24th April, you can see post-fire vegetation recovery. Means the top canopy is not impacted, only ground canopy is impacted by this. So it is clearly indicating, using the satellite data, we can say that now all the forest fires are in India happened in this region is ground fires and surface fires. Mostly it is surface fires. That's why we can able to see the post fire vegetation recovery. So there are major events happened in the 2016, the Uttarakhand fires. Most of the are aware of this. So last few decades, there is no such events. But in the suddenly 2016, there is a rise in the forest fires. Even Governor residents also under fire. Because what is the reasons with this one? This is published by our team monitoring forest fire from the space ISRO's initiative for near real-time monitoring of the forest fires in Uttarakhand, India. It is published in the current science. Interested audience can download this paper. So what we did, we have compared why this massive event happened. So we have taken all the forest fire activities from 2016 to 2020, 2016, all these fire events. And also we have used the ABIF's advanced wide field sensor to understand the active fire and the smoke burnt area. This is fine. But the thing is, why this is happened? We have taken past 100 years average rainfall in mm, and also we have taken compare with the temperature. Now we found that in 2014 15 we have a low rainfall. So once it is very linked, very low rainfall and very high temperatures leads to that devastating effects on the forests of Uttarakhand. So most of the area is impacted. Total 7 point proportion of forest is 7 point. Outside forest is more than 384 square kilometer is burnt, and 7.35 area percentage of area burnt within the um, study sites of Uttarakhand. You can see the district wise distribution of forest fires. And if you come to the India, the nationwide burnt area assessment, you can see this was published in 2017. You can see the districts. Now government or department wants to conserve the districts or administrative boundaries from the forest fires, or they want to take the management action. For that, you need a forest burnt area map at district level. We have prepared the districts which are severely impacted. For example, more than 1,000 square kilometer impacted districts. There are 11 districts distributed in Andhra Pradesh, especially in Nallamala forest region, and Telangana region, especially Khammam, that region, and Chhattisgarh, deciduous forest of Chhattisgarh, Odisha, that belt is highly forest fire prone districts. When the second 500 to 1,000 square kilometer, there are 17 districts that is also in parts of Odisha, Telangana, Andhra Pradesh, and also the northeastern states. And 100 to 500 square kilometer, 86 districts we identified in the different parts of this one. So what are the fire season? We have taken February, March, April, May, all months of satellite data procured and identified Andhra Pradesh, Karnataka, Telangana, Odisha, Bihar, Maharashtra, Madhya Pradesh, and Rajasthan, Uttarakhand, Manipur, and Arunachal Pradesh are having the highest forest fires. Now, grid-wise representation of forest fires and burnt area. Now you can see earlier I showed a case studies. Once you merge all type of case studies state by state, once you prepare the burnt area product, now you can create a 1 kilometer grid. You can show the number of burnt areas are impacted grids. For example, less than 1 square kilometer, 1 to 5 square kilometer, like that you can categorize. You can show the grids which are impacted by the burnt area, and number of grids impacted by the burnt area. We have given 20 square kilometer, 232, or this one. I mean, out of this is a 5 kilometer by 5 kilometer grid. Within that 20 square kilometer of area is burnt. 232 grids means that is mostly impacted by the forest fires, and also the burnt area. And also the second one is a burnt area assessment using the ABIFS data. there also we showed the how many areas, how many square kilometer of areas impacted by this one. So 20 square kilometer, this much about 20 square kilometer area impacted in a grid. There are 5,301 square kilometer of area is impacted by the fire. Now, there is another paper by the Reddy et al. 2017. The summary of trace gases emitted for India in teragrams per year. So how these forest fires, even it is a surface fire or ground fire, ground fire, in India mostly, as I told, it's a surface fire. Due to this fire, how much, see here exclusively we have taken only the forest, scrubland and grasslands. We have not taken the in the stubble burning, means in the agriculture field, that we have not identified. Once you identify, the number will rise. So in forest, carbon dioxide is 67.83 teragrams, carbon monoxide, methane, nitrous oxide. The other trace gases, you can see the mostly the trace gases are carbon dioxide and carbon monoxide. 98.11% is mainly emitter is CO2 and carbon monoxide, and 5% of 5.69% of the carbon monoxide from the mostly these are coming from the forest, followed by the scrublands and grasslands. Because as initial slides I showed based on the availability of the fuel load. Generally, forest has more fuel load. That's the reason we are getting more CO2 when compared to the scrub and when compared to the grasslands. So now, what are the sources of geo-portals for fire and burnt area? So for that, we need to understand this. These are the some of the geo-portals. One is a Copernicus geoportal. This is by the European Space Agency. They created for the European Union. They have Sentinel-2 cloud-free 2024 data they will give, and also they will provide the wildfire risk zones. So in this wildfire risk zone, example, high risk agriculture, aggregated wildfire risk zones, intermediate risk zone, and low risk zone. And also we can overlay the admin boundaries. We can see the how much fire, and also it will provide the danger by the weather. When large scale fire happened, that effect will be not on that same area. It will be impacted other areas. So the danger by the weather and the danger by the wildfire thermal anomalies. You can also see the some basic layer, the basic layers of fuel type, and land cover is impacted, whether it's a forest, scrubland, and this one, and the grasslands. So this is the Copernicus, this one. There is another a renowned website is called FIRMS, 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 Fire Information for Resource Management System. That is by the NASA. This NASA website will give the lot of data on forest fires, forest burnt areas, NOAA satellite, VIIRS, MODIS, Aqua, Terra, 1 kilometer level the satellite products it will give, and you can navigate to this website, and you want, for example, Indian this one, you will get it there, and you will get monthly MODIS monthly forest fire data. Here you can see, especially in the India and Southeast Asia region, most of the forest fires happened in the September in Punjab and Haryana. Especially in India, we can see the Punjab and Haryana is mostly impacted by the stubble burning, and the impact is in the Delhi region, urban region, but emitter is from the Punjab and Haryana, as I told earlier. So you can also see the other fires are the mostly in the fire in the forest are the March to January, February, March, April. These are the forest fires. So fire season type of flammable material that will determine the where is happening when it is happening. Especially you can see Myanmar, those the fires are happening mostly in the March, especially in the dry deciduous forest. So this data you can navigate for you can measure the area. You can also get the location information. For example, you want to understand forest fires in Telangana. So you can provide the shapefile or take the boundary box, create a box, and that can extract the Telangana forest fires from specific date, this date to that date, so that you can analyze that data and integrate with the satellite remote sensing and prepare the geospatial maps. And also you can go with the timeline and you can capture the screen, you can share and view mode. These are all available. There are plenty of features available in these films. So the major thing with this website, you will get the fire from the VIRS or MODIS, which is 1 kilometer and 375 meter. Means it will capture only the large fires, but you will not get the burnt area. See that burnt area also you will get it in large scale fires. But as a small scale fires, are you need to rely on the Sentinel and the Landsat imageries for more localized studies. So what about the India? India also created a one Agni geo portal by Forest Survey of India. Here you can go to this website and see the administrative boundaries and forest fire detection. And also you can go with the large forest fire detection in the past specific time period. This is also this data, the One Agni geoportal uses the MODIS and VIRS Suomi NPP data, that is 375 meter, and another is moderate resolution satellite data, that is MODIS 1 kilometer. With that data only for exclusively for India, you can see in this geoportal other nations are it's not showed, but only in India it is shown because they want to give the fire alert system to the concerned persons. So forest fire danger rating also it will give which forests are more prone to fires, and also it will provide the, you can also see the administrative boundaries in this one, and it will give different categories such as extremely fire prone, very high fire prone, highly fire prone, moderately fire prone, and less fire prone. That type of categories they can give, and we can. But this data is for visualization purpose, not for the download purpose. But as I showed this earlier one, you can visualize and as well as the request for download for the specific region for further analysis. In the films data, very important to know that we need to check the data of accuracy. There are high accurate points are also there, medium accurate is also there, and low accuracy points are also there. So that's why they kept a forest fire alert system. So that is be careful with the data. So these fires are both an ecological process. Once you understand the fire, it's a mainly an ecological process and a climate risk. Climate challenge, climate change and a climate challenge situation, the deforestation are reshaping the global fire regimes, because they are very important to understand the changing the climate regimes, because temperatures are increasing. As I showed for the Uttarakhand, when it increases temperature and availability of litter, it will create the forest fire. Most of the forest fires are the anthropogenic. So it is very important to understand when we are keeping the fire. So that is the reason there is a very important to understand this complex global fire regimes or complex fire phenomena or fire ecology, it is essential to monitor the forest fire monitoring, burnt area assessment, risk reduction towards the sustainable forest governance using the earth observation data. So studying the vegetation fires and burnt area is essential for comprehending the ecological resilience, climate interactions, biodiversity conservation, and human well-being. As a fire regime, it is currently the climate change and anthropogenic influence interacted the fire research using the, so what we need actually. So what are the data need to be integrated for making the sustainable landscape management and the informed decision making. Number one is field data is very important. Without understanding the ground, we can't approach for the further linking with the satellite data. So the second is satellite remote sensing data. The third one is to understand the people perception, that is a socio-ecological perception. So without people perception, the socio-ecological and socio-economic understanding, we can't make the informed the management decisions, because government wants to do something, but the people resist. Because people want to do something, the government resist. That's why geo socio-ecological approach is very important for sustainable landscape management and informed decision making. Yeah, thank you. So if you have any doubts or regarding this website kind of thing, or how to download this data, I'm ready to help.
Hello, sir.
Yeah.
Very nice presentation, sir. Actually, any software required to download this satellite data, sir?
For downloading, it's a good question. For downloading satellite data, you do not require any software. For example, you can go to Sentinel Hub. Yeah, that is a European ESA, European Space Agency, or a NASA. So you can go there and download the satellite imagery. You can, but for visualizing the satellite data, you need a softwares. I can suggest some softwares. There are three types of softwares. One is a commercial. Another is mainly two types. One is commercial softwares and open source software. Another is a free, but you can utilize this open source software like a QGIS kind of thing for initially visualizing and band combination. So once after downloading the satellite data, you will get all different bands. In a photograph, you will get different bands. So like this, once you merge all these bands, you will get a colored image. So that is what software will do. For downloading satellite data, absolutely you don't require any software.
No, to make the data in Excel, what to do, sir? Excel depend on the areas, how to do, what to do.
Yeah. So there is another way to download the forest fire data, fire counts. That is a forest fire. What I told previously, that is forest burnt area. So for that, you can download this from the NASA website, that FIMS, as I told, that forest fire alert system. Select the study site. For example, you are from certain region, you want to study that region or that district or that state. you give and dates. Mention the dates from date to 2 dates. After that, you will get the confirmation email. You need to register first. Once you get the confirmation email, you can download the data in CSV format. Once you get the CSV format, that is having the lat long, so that you can use it as showing the geospatial data. And also in Excel also you can show weekly how forest fire counts are happening, or a daily forest fires are happening, high confidence, low confidence, and that all you can assess through the using the satellite data and also this fire count data in Excel. The both are possible.
Thank you.
Yeah.
One more question, sir.
Hello.
One more question, sir. Which satellite can give accurate precision of the quality of data, sir?
Actually, there is no such a hardened thumb rule. For example, you always go with a multi-source satellite data. Means don't rely on one satellite. See, as I told, when satellite passes from in a region, only large scale forest fires are detected through MODIS. But if you use MODIS plus Suomi NPP, which is 375 meter pixel, it will capture the fire. You will get some more fires. That's why when you compare to the MODIS satellite, you will get more fire incidents in the Suomi NPP or this VIIRS. So that is the reason it is very important to understand to which satellite data for what purpose. You are using for more localized, I suggest use multi-temporal and multi-source satellite data so that you can understand both fire count as well as the burnt area. For example, Sentinel is having every 5 days repeativity. Landsat is having 16 days repeativity. EIACP having some repeativity. For example, EIACP is 56 meter. It is 30 meter Landsat. And also Sentinel having 10 meter repeativity, 10 meter in spatial resolution. So you always see the spatial resolution, spectral resolution, and temporal resolution. Once you understand how frequently it is revisiting and what is the scale and the revisiting time and what is the spectral bands and what is the spatial resolution of that area. Because you want to capture small fires, you go with the Sentinel. You want to capture at national scale or in a quick time, you have to go with this. So more precision will come with a high resolution data when you focus on the specific areas. So better to go with a high spatial and temporal resolution.
Thanks. Thank you very much.
Yeah. Any other queries?
Thank you so much for the wonderful class, sir.
Thank you. Thank you. So hope you understood on the fire ecology and forest fire and burnt area in the different forest ecosystems. And if you have any doubts, you can direct DM to me, or now also you can have some time, you can interact. If you have any basic doubts.
Sir, any precautions can take to resist the forest fire, sir?
Yeah, it's a very good question. Actually, that's called forest management. So we can't resist the fires. So, but we can say that we can prevent or mitigate the forests. So number one is the creating forest lines or forest fire lines. It is called forest fire lines. So especially in the Western Ghat regions, you can see having the forest fire lines. That is very important to understand why, what is the role of these forest fire lines. So these forest fire lines, so anybody knows this forest fire line? Have you heard this before?
No, sir.
So this is the forest fire line, means earlier, one second. One second. Earlier, see, before fire, I will explain the fire line. This entire stretch is a fire forest. In that, once fire will happen at any corner, it will spread entire area. To prevent this, the forest department maintain the fire lines. The fire lines is a septum or is a cross section between the two forests. There is a like it's a fragmented area. There they will clear all these grasses or woody debris and they will burn it. So before the fire season, they will burn this area or they will clear this area so that the fire cannot enter into one beat to another beat or one area to another area. So to prevent massive fire events, especially in the wildlife areas and protected areas and national parks, tiger reserves. This type of approach they will use, especially in the grassland ecosystems like Shola grassland ecosystems. They utilize these fire lines to maintain this one. This is called, this method is known as a prescribed burning. Prescribed burning by the forest department. You can also see in Bandipur, Nagarhole, Madhumalai, these areas. This is a very common management practice by the conservationist or forest department. So that even these forest fires, especially these fire lines, also detected as a burnt area, even though it is a purposeful for, I mean, as a part of the management of the forest. But satellite doesn't know that you have kept purposeful or it is a management practice. It will capture all the forest fires. So this is also one of the research area where you need to identify the forest fires, means all are anthropogenic. Within that, there is a part of management practice. There is a part of prevention of large scale forest fires. So that all very important. So in Uttarakhand, in 2016, that was happened. That area not having adequate forest patches, I mean forest burnt patches or fire lines. So that is the reason previous year also we have a very less forest fires, but a lot of material is available, and these pine forests are also having the flammable material. That is the reason once the fire is happened, so it will catch entire area burn. And also Himalayan region, you know, a lot of winds are there. And at the same time, the previous year is a drought year. So that is the reason. One is temperature. Secondary is first is availability of fuel. Second is temperature, and also rainfall. Temperature is interlinked, and the third is the anthropogenic activities. Once these four are available, you can see the lot of forest fires and the burnt areas, and create the lot of emissions and the atmosphere. Again, it is a link to the climate insights. So these forest fires can't be seen in a one specific area. It should interlinked and should be seen in the climate perspectives. That is what is very important for understanding the geospatial technologies towards the achieving sustainable development goals.
Thank you, sir.
Yeah, welcome. Any other queries? So you have another 15 minutes of time. You can interact regarding the satellite data or biodiversity, forest, whatever the covered topic, or how to interlink this with the emission data, anything from your end.
Good evening, sir. I have one doubt.
Yeah, please.
Sir, now you are telling about Mudumalai forest fire.
Yes,
Could you show me how to download that data from satellite images or satellite data? Hands-on, how do we can use that satellite data download options from various websites?
Okay. I'll show 1 second. Now I'm navigating to that.
Sir, you are stop screen share, sir. Please stop screen share.
Sorry?
You were stop screen share.
No, I am sharing now. I am sharing.
Okay, sir.
Yeah, I shared now. So there I'll show a quick and easy method to you. Now you are able to see this?
Yes, sir, we can see.
Yes. Okay. One is this product. This is our Indian Geo platform of ISRO, that is Bhuvan. Okay. First, you register for this. Okay. After this, you will get different plenty of data categories. You will get it. One is satellite and sensor. Another is the thermal products. So you can see the theme of the product. ISRO Geosphere Program, NICE is under, this is a National Information System for Climate and Environmental Studies. These are all there, and you will also get a CARTO DEM. Okay, DEM means this type of one. So for satellite data, you want to get it. CartoSat 1, ResourceSat 1, List 4, List 3, these are all. So ResourceSat 2 or something we are getting. So you need now available in the Bhunidhi portal. So it will show where to you go. So this is in the Bhunidhi portal. So like this, you need to navigate to the Bhunidhi portal. If I directly show the Bhunidhi, you will forget about the this portal, our Bhuvan portal. So first you should understand that as per the new geospatial policy, 5 meter and above data is free of cost giving by the Indian government. But only thing is you need to register for it. And from May 2024, all commercial activities with respect to IIRS satellite data product being handled by NSL. So this is one information will come. Then, for example, if you have a shapefile, Madhumalai Tiger Reserve shapefile, you go here and upload shapefile. Okay, existing shapefile, or you have a this one, you can select it, or you have a location. There you can go to select Madhumalai. Place name is Madhumalai. Sometimes it will come. See here it is coming. Madhumalai, Tamil Nadu. So you have to click here. Now you got the Madhumalai area, but it is coming as Madurai, sorry. Madhumalai is a tiger reserve actually. So you need to get a specific shapefile or a polygon. So after getting this example, which data you want? For example, you want 1st April to this April. Then you go with the, you need to select the satellite here. Open or priced. You have to go with the open data, or you want to purchase this satellite data. That is another thing you need to pay. And the second one, you need to check with the resolution. So 5 meter to 25 meter. So you take this. Okay. And also you take 25 to 100 meter. Then satellite. You have to select a satellite. Landsat 8 or a Landsat 9 or a Cartosat or Indian satellite data. Whatever available satellite data sets, you have to navigate it. So I have selected Landsat 8 and I have selected Landsat 9. And I also selected ResourceSat 2A because 5 meter above data I want. So you should read all these ResourceSat 1, ResourceSat 2, then you can go. Then select the sensor. And Landsat means you should go OLS. You have to go with a list 4. Then you will get a product, level 1 or level 2. So this level 2 is a ground rectified, geo-rectified. So for what reasons you are taking, this is optional. You can say land use, land cover, or a fire. There are some themes are there: geohazard, urban, water, dam, flood, and this one. So you are taking this for land use, land cover. Yeah. After wrapping, open data, direct download. Resource set to list 3. So once you have all these in your hand, now go for submit. Like this, all the satellite data will come. For example, you want for your Madhumalai, because we have not uploaded a Madhumalai satellite data shapefile. For example, here it's a open data. See, you can see here, example, this much big tile is there. In this tile, all reds are forest, agriculture, or vegetation related, and other is a desert. So once you have seen, this is a cloud-free data. Once you have a cloud-free data, now you go with the where it is image extent, then publish to map, or go to add to cart. Once you go to add to cart, you have to register it, your username and password. Okay, this is my username. So once you log in, sign in with the username and password. Once you log in, your data will be downloaded for any reason. This is one. Another is another. I will show another thing. This is from Bhuvan web portal. You will get all type of satellite data instantly. And second is so another is USGS, that is a NASA website. So in that also you can select the data sets. And another is there. Yeah, I'm sharing the screen again. Yeah. Now you are able to see. You can type
Yes, sir.
Earth Explorer usgs.gov.in. There it's a NASA website. Here also you can use data sets. First you need to check the data sets, which data you want. There you have plenty of options. Generally, this website go for a digital elevation, AVHR, and Landsat. So here Landsat data you have. You have a Landsat collection 2, Landsat collection 1, Landsat collection 2. Landsat 8 or 9 we have selected. And additional criteria you need to go. Type of satellite and this, and then go to search criteria. Here you have a two feature. One is feature name or state. Okay, you can go feature type. Feature name is you can say so. This is US features. There are world features. You need to go with a world feature. You need to check for the country. There you go to India. This is a long process actually. Administrative boundaries and features, then feature type. So you have a first order administrative boundaries and show. So for entire India, it will show. So here you will get it, which state you want. So it's a long procedure. Once you have a Madumalai Wildlife Sanctuary, directly we can go and do that. See, for example, I am this is one state of Kerala. Just click on state of Kerala, automatically it is redirected to Idukki, Kollam, this one. But you want directly Kollam, directly you can take this. See, automatically the lat longs have been taken. Or if you have a predefined area, you don't want all these, you want Madumalai Wildlife Sanctuary. There is a easy option called, or Madumalai is here. Hope you can understand. Here, yeah. This is Bandipur National Park. This is OT. This is Madumalai area. So you have to select like this. For example, we have taken like this. So like this, four corners you take it and then select the dates. So you go with the search from which date to which date. So you need to go with a January 2025 first to current date, means today's date. If satellite pass today, that data also available for tomorrow or today night. So then you go with the results. So available. Now your Madumalai Tiger Reserve area, you need to check with the footprint. So your path is 144.52. So this entire area is having Nilambur, Gundulpet, Ooty, Wayanad. All these areas are there now. So this study site. So now you are able to get the one satellite data. Then you go for a download option. For that also you need to register here. Login. You have to log in by creating a username and password. There is another important is there ESA, European Space Agency, Copernicus. Here you can see from single date to multiple dates as I shown previously. See, for example, all these data sets you can see here, one shot. So you have to select it, but you need to log in here. But you need to visualize a search Sentinel-2. For example, most widely used Sentinel-2, level 1, level 2, that are all available here. So accordingly, you need to select the data and visualize, geo-visualize, and download the data. And somebody interested in geophysical parameters, that also you can see. You can see the digital elevation model, and also you can see SAR data. You can also see the atmospheric, the Sentinel 5P, means where you can see different type of pollutions. Also you can see atmospheric pollutions. That data is also available for the analysis and download and analysis. So this is all from the ESA and NASA, USGS, and our Indian Bhuvan. So that you can see here.
Thank you so much, sir. Very informative, and we have learned so many things from you, sir.
Yeah, thank you. Thank you. So I hope you enjoyed the lecture and you learned something from the forest fires and vegetation fires and burnt area assessment using the different techniques and as well as the case studies and the what are the global and national geo-portals for supporting the this type of analysis fire. Once you analyze the fire and then you can go for the emissions for the climate, understanding the climate perspectives. So thank you for the opportunity. Darga Sahib, sir, you want to say something? Yeah.
Yeah. Hello.
Yes. Yes.
Yeah, Dr. Rosas, sir.
Yes. Yes.
I think we can wind up now.
Yes. Yes. I think we have addressed all the queries. If anything,
Yes,
they can DM to us. We can query. We can
Yeah,
do
yeah.
that. And yeah, we finished on time.
Okay, on time. Yes. Thank you for that.
Yeah. Thank you.
So, okay, fine. We will meet. Thank you to all. Tomorrow we will meet in the same time.
Yeah. Thank you, one and all. Yeah.
Sure.